Good day, friends. We are back again with another summation formula. Last time we talked about 1 plus 2 plus 3 up to n. This time we are going to take, of course, the natural numbers up to n, but the squares. We'll take 1 square plus 2 square plus 3 square all the way up to plus n square. And we are going to have a look at it through the model. We first write down the formula for this summation. The formula is like this. Sigma k equal to 1 to n of k square. And what do we mean by this? We take k equal to 1, 2, 3 up to n, and we have to take the square. So we take 1 square, 2 square, 3 square, and so on, all the way up to n square. And then we have to take the summation. So this is the sum of all this. And the formula is, which we are going to verify now with the help of the model, n into n plus 1 into 2n plus 1 upon 6. Okay. So, there are 3 parts here. These two are identical, and this is a third one which goes in between. Now, how have these been taken? We try to understand these parts, and that will also tell us how to make them. For example, we take one of them. Now look at this part. This is our 1 unit. This is 1 square, 1 by 1. So this area is 1 square. Now we add one more. So what we have added, we had this. Now we have this one more, and that is 2 by 2. That is 2 square. Then we add one more, that makes it 3, and we take 3 by 3, that is 3 square. Similarly, we add one more, that is 4, and we have 4 square. This is 4 square, and similarly this is 5 and 5 square. Now this is the same. Now what does this mean? It means that the total area here is 1 square plus 2 square plus 3 square plus 4 square, and we shall not say that this is 5. We shall say that you can have as many in between as you like. The last is n. So 1 square plus 2 square plus 3 square and as many as you want plus n square. So this total area is exactly what we want. 1 square plus 2 square up to n square. Now these are identical. So this is also the same. That is one thing we note, and that is how we make this. Now how do we make this middle part here? This is the middle part. How do we make this? Well, we make it like this. Going back to the original. This we saw. How much it is? It is 1 plus 2 plus 3 plus 4 plus 5. Total length is 1 plus 2 plus 3 up to n. And that is how much? We know it. 1 plus 2 plus 3 up to n is sigma n, or it is n into n plus 1 upon 2. Now remember, this is the length of this side of the rectangle. Now the other one, this side, this is n. This is also n, and as you can see that this was our 1 unit, this is also 1 unit. So this length we have taken in the rectangle as 2n plus 1. So the entire rectangle has the area. This is the area of the entire rectangle. That is one thing we know. The second thing is that once we have the rectangle, once we have these two pieces, what remains in between is precisely this. And that is how we make our third piece. Alright, now what we want to do, we have already seen that the total area of the rectangle is n into n plus 1 into 2n plus 1 upon 2. It is very similar to what we want. What we want is upon 6. That means that this is 3 times that. Now if it is 3 times, we know that this is 1 times, this is second time. If this is also the same as this, then the entire area will be 3 times this area or 3 times this area, and we will get our result. So now what we are planning to do is to show that this middle portion is precisely has the same area as this. And how do we do that? Well, that is why we have cut this into small pieces. The cutting of small pieces you may do like this. The central one is the whole one. Next to it, in this little groove, we don't make a whole one. We take 2 equal parts. So we have 4 equal pieces here. Similarly, 4 equal pieces here, and just these 2 pieces single and these small pieces as they are. Now we want to arrange all these. We want to say that this area is equal to this blue area. So this area is all these small ones. We'll take them and put them on this. If we can do that, we are done. Okay. So now what we do is, on this we want to arrange all the small pieces. We start with this one, and it goes over here, the longest length. Then the next ones will go here. There are 4 of them. Now we knew that this length was 5. 1 is gone already, and we have 4 more, so it should take care of the entire square. Then the next one is this one. They go horizontally. And this was 4 by 4, 1 is gone, so this is 3 now. So that is how it fits here. And now these 2 over here. And the unit squares over. So now we see that these small pieces have all covered the whole blue piece, and therefore the area of this, which was here and which was filled up by these small pieces, is the same as this blue piece or this blue piece. In other words, the 3 parts that we have the same area, the 2 blue ones and this one, and this is how we show it. Alright, if the 3 parts are equal, it means that one of them is 1/3 of the whole. And this is what we want. This is our sigma n k square. Okay. So if this is 1/3 of we want, we know that the whole thing was this. This was the entire rectangle. And we want 1/3 of it, and that makes it precisely n into n plus 1 into 2n plus 1 upon 6. So that is how we get the verification of this formula with the help of the model. And now, a little puzzle that is associated with this model, or with this formula rather. You take a square. We are taking squares and going to divide and subdivide and see how many squares we have every time. Here we can see it's 1. Here we have divided by one horizontal line, one vertical line through the middle, and that is 1, 2, 3, 4 and the whole one 5. Okay, here we are dividing by 2 vertical and 2 horizontal, 3 horizontal and 3 vertical, 4 horizontal and 4 vertical, and so on. You can go to any extent, n maybe. And every time you have to count the number of squares that you have in all. Now 2 things to be noted about it. Number 1, when you count, remember you will count like this. I'll show somewhere here. 1, 2, 3, 4 single units. They are 16, 4 by 4, 4, 4 and so on. Then 2 by 2, this is 2 by 2. Then another 2 by 2 you will get here by moving like this. Another 2 by 2 by moving one more. You will get 3. Similarly, you will get a 2 by 2 here. And then a 2 by 2 by moving downwards. This one by moving downwards. So, if you have a system that you move one unit to the right or one unit downwards, then you will not miss any or duplicate any. That is one tip. And what we have to do is, while counting, what is the fun in doing it? The fun is that if you note down that the say for here, single unit 16, 2 by 2 so many, 3 by 3 so many, 4 by 4 so many, then you will see that there is a definite pattern in those numbers as well as these numbers that you get totally. And that pattern is directly connected with our sigma k square or 1 square, 2 square up to n square. Okay, see if you can find out the pattern. Thank you.